Hi Goenkans, let us continue our study of chapter Quadrilateral, page number 35 to 42, exercise 3.1. We were discussing the concept of polygon in quadrilaterals, and this is our third lecture on this topic. Yesterday, I have given you people three formulas to find the sum of the internal angles of polygon and to find the number of sides of a polygon and to find the each internal angle of the polygon. Now today I am going to give you certain more formulas of the polygons which will help you to solve different uh, questions of the exercise 3.1 as well as 3.2. One formula among them is this. If you want to find the number of diagonals of the polygons without drawing them, you can use this formula. You see, when you draw a polygon, it is easy to find its diagonals. But when you do not draw the figure of a polygon and uh, you can say like this, a polygon has uh, uh, so many sides that it is impossible to draw them uh, uh, on the page of your notebook. Then the formula which you will use to find the number of diagonals is this: n into n minus 3 divided by 2. For example, if I say find the number of diagonals of a polygon having 100, 100, 150 sides, it is impossible to draw such kind of polygons. So uh, uh, then you can use this formula uh, to find the number of diagonals of the polygon, which is n into n minus 3 divided by 2. Here n represents the number of sides. Let us do an let us do an example here to make this concept more clear. For example, I have given a question here: find the number of diagonals of an hexagon. So here we know hexagon has how many sides? It has 6 sides. So when you want to find its diagonals, you will do it like this way. N into n minus 3 divided by 2 is the formula. You will write it first here. Okay. Then in place of n, give 6. And again you have n, give again 6 minus 3 divided by 2. Take 3 out of 6, you will get 3 divided by 2. Then reduce it. You get 2 ones are 2, 2 3s are 6, 3 3s are 9. So there are 9 sides or diagonals of the hexagon. So in this way you easily find the number of diagonals of any polygon with the help of this formula. Okay, this is one concept, that you can use this formula to find the number of diagonals. Now the second one is this. We know the sum of the internal angles of quadrilateral is 360 degree. It is for a quadrilateral only. But there is a property that every polygon, whether it is a triangle, quadrilateral, pentagon, hexagon, heptagon, or any other polygon, the sum of the external angles of the polygon is always equal to 360 degree. This is a property, that sum of the external angles of polygon is always comes out equal to 360 degree. Let us take an example here. Example of a triangle. Say ABC is a triangle, and angle 1, angle 2, angle 3 are its external angles. Okay, and internal angles I have given here 30, 70, and 80. So if you want to find the external angles, say for example you want to find external angle 1. So you know angle 1 plus 30 is 180. They are the linear pair angles. So if you want to find angle 1, you will get it like this, say 180 minus 30. So it is 150 degree by the linear pair angles rule. Similarly, 2 plus 70 here. 2 plus 70 is again 180 linear pair. So angle 2 will be what? 180 minus 70. So it will be what? 110. Similarly, you will find angle 3, which is equal to 100. Now, when you add all these external angles, such as 150 degree and 110 degree and 100, that is 1, 2 and 3 angles, they will come out equal to 360. This proves that a polygon always has external angles equal to 360 degree. You can prove it for quadrilateral. You can prove it for quadrilateral, pentagon, hexagon and any other polygon with the same method which I have shown you here. Okay, then move onwards. So this formula which you now have learned, that sum of the external angles of polygon is equal to 360. This can be used now to solve so many problems given in your exercise 3.1. Okay, now move on. One more thing which you already know is this: sum of the internal angles of quadrilateral is 360 degree. This should also be kept in mind while doing the questions of the exercise 3.1. Okay, I will show you some typical questions of exercise 3.1 and 3.2. Rest you will practice yourself. Okay, now look, the first question of exercise 3.1 is find the value of x. It is actually question number 6 of exercise 3.1, and it says if there is a figure A, B, C, D, E, this one, which is having how many sides? 1, 2, 3, 4, 5. So it's a pentagon, and there are given angle A and the external angle 70 and external angle 60, and we are being told to find the value of x. So first what will we do? We will do it like this way. By the linear pair method, we will find here internal angle 1. 1 plus 70 you know is equal to 180 by linear pair. So angle 1 will be what? 180 minus 70. So it will be 110. Similarly, 60 and angle 2 forms a linear pair. So angle 2 will be 180 minus 60, that is 120. Now, we have got angle 1, 110, angle 2, 120. And we know sum of the angles of pentagon is 540 degree. It should be in your mind. If you don't remember this thing, then you can find it with the help of this formula which you already know, n minus 2 into 180. So in place of n you put 5 because pentagon has 5 sides, minus 2, so you get 3 into 180 you get 540. So this gives you the sum of the internal angles of what? Pentagon. So then we will do it like this here. We know now sum of internal angles of pentagon is 540, so we write 30 plus 110 plus 120 plus x plus x is equal to 540. So you add these 30, 110 and 120, you get 260 plus x 2x, so 540. So 2x will be there, 260 will be transposed here, you get minus 260. So when you take out 260 out of 540, you get what? 280. So 280 is divided by 2, you get 140 degrees. So value of x is here what? 140 degree. So in this way you have find the value of x. Hope you understood. Do the other questions likewise here. Now in exercise 3.2 there is a question again of the same kind, but it is here of based on the sum of the exterior angles of the polygon, and you know sum of the exterior angles of polygon is what? Always 360 degree. So we have here a triangle ABC and its exterior angles are here 125, 125, and angle X is missing and he wants us to find it. So sum of exterior angle is equal to 360. So you write 125 plus 125 plus x, sum of the exterior angles. So it will be what? 360. So you add them out, 250 plus x is equal to 360. You transpose it here. So value of x is 110. So in this way you have used both formulas, sum of the interior angles of quadrilateral and the sum of the exterior angles of what? Sum of the exterior angles of a polygon is 360, and with the help of these two formulas you will be able to do exercise 3.1 and 3.2 easily. Hope you have understood. Thank you very much.